So good morning everyone, my name's Keith, I work at ANZ and I'm going to talk a bit about the journey that we've been on over the past sort of 8 months in our implementation for Puppet. So I'm going to cover off who I am, a bit about the business that we're in, some of the challenges that we've run into over the last couple of years through the growth in our business, the approach that we've taken to addressing some of these challenges, and then I'm going to dive into the lessons that we've learned in implementing Puppet in trying to address some of these challenges, also known as things I wish we knew at the start. So I'm going to cover off some things that are probably not necessarily beginner Puppet items, but the idea with that is that the idea is that you know, you'll leave here with an understanding of some of the solutions that are available in Puppet that you wouldn't necessarily know coming to Puppet cold, and when you encounter perhaps some of the challenges that we've run into, you can think back to this and identify some of the solutions that we've implemented. And then finally, I'm going to talk about an interesting piece of work that we've done around storing sensitive data in Hira, and I think that's something that is I haven't seen anyone do in the Puppet world previously. So I guess the business that we're in, so GSIS, ANZ GSIS stands for the Global Customer Integration Solution. So the build for the GSIS platform was started around about 3 years ago. And the intent for the platform was to build an environment that could deliver niche client-facing integration solutions that could solve transactional banking, the transactional banking needs of ANZ's institutional bank clients. So our customers typically started around $50 million in revenue and go up from there. So we're talking about corporates, large corporates, other financial institutions and governments. So on the GSIS platform, so the GSIS environment is a technology environment that's independent of the broader ANZ group technology function. So I work for the institutional bank business, and the GSIS platform is an asset of the business. And on the platform, the first channel we delivered is a channel called ANZ File Active. So the goal with ANZ File Active is basically to provide a channel that facilitates the direct connectivity from a customer's core systems through to the bank's core systems for processing of things like payments, and then providing information about payment receipts and other transaction banking services, as well as things like trade finance. So the customer base that we service is global. ANZ obviously has a super regional focus, so we've got a big focus across Australia, New Zealand and Asia. And from the build of File Active and delivering this core integration capability, we've then over the past 3 years grown the offering on top of the GSIS platform. So we're delivering additional channels and services that utilise that core capability of integration to expand our offering to the market. So I guess to give a sense of kind of the scale and the environment that we're working in, some metrics around the past 2 years of our platform. So 2 years ago, we were processing around about $3.5 billion a month in value. Last month, we processed nearly $30 billion a month in value. So Luke spoke a little bit about 5 nines and measuring availability. So one of the interesting things once in the financial world is when you have metrics like this, you can quantify not that your availability is X nines availability, but we can quantify that. We process $2.7 million a minute. Every outage in our environment is a every minute of outage in our environment is a $2.7 million outage. Similarly to customer growth, so we've experienced essentially linear customer growth over that period, and that doesn't look like it's going to be stopping anytime soon. So how do I fit into this world? So I'm responsible for leading the development function within the Jesus environment. So within my group, we've got around approximately 40 people, split into 4 agile delivery teams. So the vast majority of people in my group are either developers and testers. We have a few solution designers as well as iteration managers as well. I hate to break it to probably a lot of you, but we're a Windows environment. So I'm going to talk a little bit throughout this presentation about Windows, but I think it's actually a testament to the maturity of the Puppet stack and the Windows environment that the main focus I'm going to be talking about for Puppet and Windows is actually nothing to do with Puppet on Windows itself. So in our environment, currently we've got about 50 servers. We're heavy users of the Atlassian kit, so talking about Stash, Jira, Bamboo. We use PowerShell a lot, and looking at this from March 2014, the way we got stuff done was essentially remote desktop and a whole lot of elbow grease. So things we do well. So continuous integration and deployment automation is something that we do a great job of. Once we've got an application deployed across all of our environments, we can iterate on it, I think, exceptionally well. In the environment that we've got, we ship typically about 5 releases to production a month, and in our non-production environments, we do about 2,500 deploys a month. We do about 3.5 million test executions. We use Cucumber for UI test automation, and we do test automation quite heavily. But things we need to do better. So management of complexity has been a big challenge for us. So in an environment where we've been growing quite strongly, in an environment where the value that we deliver to the business is our ability to deliver new channels and services. Complexity is a big threat there. In terms of actually delivering change, so as I said, once we get an application out to an environment, we can iterate on it like crazy. But actually getting a new application out is difficult for us. And then third level support and operations. And so that's about the increasing responsibility that we are seeing with the growth in customers and the platform. So the first challenge, so dependencies and change. So what we have is essentially, imagine a UAT environment, and you've got 6 channels that have various degrees of interrelationships. 3 of those channels are being actively developed, and they're on different release cycles. We end up in a point where one of the channels can't actually get the UAT environment in the right state without a lot of manual rework to back out versions of other dependencies. So where we want to get to is for each project to be able to have its own environment on an as-needs basis, and for each project to specify any dependencies that it needs to take in terms of other dependent applications and services, so that all of those delivery streams can continue on without having to interact and collide with each other through the delivery. So the other challenge is growth in channels. So we started out with FileActive in 2012. 2014, we've now got six customer-facing channels on the environment. We'll be shipping another 3 next year. So with that, we see ourselves, and the growth in the customer base, we see ourselves taking on a lot more third-level support and operations. So a challenge there is that our team has little to no production access across the group as it has grown. There's no broad knowledge of the production infrastructure. We found ourselves far removed from production incidents, so it would take typically an hour to get from first level support to us for us to start to look into a serious issue. So the approach we took was we've employed 3 separate tools. So App Dynamics is a tool that we've chosen so that we can start to have greater insight into our applications as they're running in a particular environment. Splunk provides us centralized logging so that a member of my team can get a view across our entire infrastructure stack without having to actually access any servers in the environment, and then Puppet for configuration management. So I'm going to be talking about the Puppet aspects for the rest of this talk. So Public enterprise versus open source. Luke touched on this earlier. I think it's just worth mentioning kind of our reasoning for taking the public enterprise stack. So you know, we're a business team. We're focused on delivering business value. Given a choice of having to deploy and integrate all of the individual open source components of Puppet versus taking the enterprise installer, it's kind of a no-brainer in our environment. You know, the last upgrade for Puppet on the master took us something like 10 minutes. So our approach in implementing Puppet, I think, is something that's worth explaining. So the first thing we did is dedicated somebody to having a look at it. So I highly recommend graduates. They're a cheap, or in our case, IVL students, free source of labour. So we dedicated someone and just asked them to just get their hands dirty, spike Puppet, try and understand it. And so when you start that process, you'll get in the documentation, and at some point you will find this. So I've got this up not to explain it, but to highlight that, you know, one of the key learnings that we had at this early point is Puppet's a tool. So there are an infinite number of ways that you can actually use Puppet. Puppet is not out of the box a solution. The important thing about getting value out of Puppet is actually architecting the right solution. So we had a go at it. We identified kind of the right questions that we needed to ask, and then we got help from people who knew what they were doing. So we trained a core group in our environment. We went through the Puppet fundamentals training. We implemented the framework, and then we're in the process now of expanding that more broadly across the team. So I think it's important to highlight, you know, we found that by having it go first and learning some lessons and identifying the questions that we wanted to ask, we got a lot more value out of the Puppet fundamentals course than if we'd just shown up cold and started, for example, trying to learn the Puppet language at that point. So into the lessons. So I'm going to cover off a broad range of things. I'm not going to go particularly deep into them. I'm going to provide links to further reading or Puppet Camp talks from people who know what they're talking about a lot more than myself. So I guess the first thing is Puppet is code. So in code, abstractions matter. If you don't architect a piece of code properly, it will not be understandable and it will not be maintainable. Puppet is no different. So there's a pattern that's taken hold across the community, and I've got a link down there to a presentation from Craig Dunn, who's sort of done a lot of work in defining this pattern. The roles and profiles pattern. So I see this as implementing two things that are vital to a good software architecture. Firstly, separation of concerns, and secondly, composition. So in classifying a node using the roles and profiles pattern, you give each node a single role and only one role. You then compose, a role is then composed out of one or more profiles, and each profile is then composed of a number of module declarations. So what does that look like? So here's an example that I've, again, stolen from someone else. So this is an implementation of a roles and profiles model for a WordPress site. So on the left-hand side, you have a node declaration that says this needs to include the WordPress role. Inside the WordPress role, you're then including particular profiles to install, for example, MySQL, MySQL PHP, and then WordPress. And then, as an example, on the database profile, you then declare what you want your SQL server to look like. So, what does that then mean? Well, if you want to change this later and, for example, pull apart your MySQL implementation so that your database server is independent of your web tier, by virtue of implementing the roles and profiles pattern, you can just simply declare two new roles, a WordPress web server, a WordPress database server, and then inside those roles, just include the profiles that you've defined already. So your implementation in terms of your architecture has not changed at all. You've just composed some different roles from your existing profiles. So from a maintenance perspective, that makes a huge difference. So classification. So out of the box, the easiest way to classify something is site.pp. You can specify node names, you can include profiles. And this works very well in a fixed environment, so you can version control site.pp, and if things don't change often or you don't want to do dynamic provisioning of environments, this works well. There are other solutions, so you can use, for example, an external node classifier or the Puppet console. Luke's also spoken about the Puppet node manager that's coming out soon, and that's something that we're looking forward to getting our hands on. But where we've gotten to is a slightly different solution. So classification at the node. This inverts the typical classification process. So the first thing to do is define a fact, define a custom fact that is the role that you want a particular node to take on. From there, your site.pp disappears. The only thing that you have in your site.pp is something that includes based on the role fact that's defined. Our implementation of the role fact at the moment, we actually scrape out the role from puppet.conf on the nodes. So this has a nice side benefit in that for us to actually perform role definition, we can do it as a remotely invoked command. So rather than having to drop a file into the facts.d folder, we can just, for example, using PowerShell remoting, run puppet config set role and then the role, and away we go. So there's some things to keep in mind with this particular solution. So this is a very simple and flexible solution. It's fantastic for dynamic environments. If you're using Vagrant to do provisioning of dev environments, the fact that you can just spin up a Vagrant box, puppet config set role, trigger a run, it's fantastic. But where you do need to be careful is if you're running a puppet master that services, for example, multiple divisions in an organization, this isn't a secure way to do classification. You could have someone who's got admin access to a server in one division just spin up an instance of another division's servers and get all of the potentially sensitive information that comes along with it. And the other con is that node classification is not version control, and that's down to individual preference as to what you'd like. So, bear with me, all of the non-Windows people. This is where we're going to go Windows for a little bit. So for the Windows users, can I have a show of hands of people who use Windows but haven't heard of Chocolatey, please? All right, I'm going to change a couple of people's worlds. All the Unix people are going to laugh because they've had this for years, but so Chocolatey is like Yum or apt-get for Windows, essentially. So the idea with Chocolatey is it's driven by a combination of PowerShell and NuGet. And once you've got Chocolatey installed, you can do fantastic things like fire up a command line, type choco install node.js. It'll pull down npm, install it, pull down node, install it, set up your path, and away you go. Chocolatey exists essentially as a first-class citizen in Puppet. There's a Puppet module that implements Chocolatey package provider. So as a really quick example, you can declare an array of Chocolatey packages that you would like, and then just have those be installed for you via Puppet. So this is fantastic, but we have a couple of challenges in our environment. So we process nearly $30 billion a month. Our environment needs to operate with a high degree of assurance. There are some challenges in the implementation of native implementation of Chocolatey, principally trust and package availability. So I hope I don't have to explain this to everyone here, but it's really not a good idea to download things that are made by strangers from the internet and install them on your production systems. So on the trust side of things, Chocolatey, it has a fantastic community around it, and for a personal device, I use it all the time. But in the type of environment that we're operating in, we need a slightly higher degree of assurance. And the other one is package availability. So I don't think, for example, there's too many people who are highly motivated to build packages for the IBM WebSphere MQ client installer to make them available on a public gallery. So how have we then addressed this? So we've implemented a workflow whereby we host our own private Chocolatey feed internally in our environment. We have a single monolithic repository that we host in Stash. All of the package declarations are version controlled in Stash. We have a binaries archive that we host within the environment, and then we have a build process in Bamboo that that basically runs the chocolatey packaging process and takes the artifacts that are output, pushes them to IAS where a new get feed is served out. So on the trust side of things, Chocolatey has a good feature around checksum verification. So from our implementation perspective, what this means is the person who defines the Chocolatey package will specify the known checksum of any install media that are included. And so that gives us an additional layer of protection if, for example, someone were to swap out a package installer in our binaries archive. When our individual nodes receive that package, it'll fail to install because the checksum won't match. So that's the Windows stuff done. I promise there's no more Windows. So talk a bit about workflow in R10K. So Luke mentioned R10K a little bit earlier. And this was something that I took a little bit of time to come around to, mainly because I didn't really understand it properly. So in trying to identify whether or not you should use R10K, you really need to ask yourself a few questions. So do you want a single puppet master to serve multiple different environments? Do you want to be able to spin up dynamic environments and operate them from a puppet master? If so, you want to use R10K, trust me. And the other thing then is, do you want to then manage your module dependencies in a declarative manner? So the best way to kind of explain this is an analogy. So if you're a Ruby dev, you're using Bundler and Ruby gems. If you're a .NET dev, you're using NuGet. Java, you're using Maven. The Puppet file implementation is basically like a gem file, but for Puppet modules. R10K implements the workflow that sits behind the Puppet file to make sure that your Puppet master has all of the modules that are required based on what's defined in that Puppet file. So a bit about how R10K deployment works. So again, heavy users of the Atlassian product suite. So a commit into a particular branch in Stash triggers Bamboo. I'll touch a bit on why we actually have Bamboo in the middle in a minute. Bamboo then fires a webhook call to R10K on the Puppet master. We actually use Zach Smith's R10K configuration module, and that implements the webhook workflow. And then once the webhook's received, the Puppet master will pull down the latest code from Stash, and away we go. So at this point, I think it's worth touching on the governance side of things. So as I said, we're a high assurance environment. We don't just allow people to commit to environments, push that straight out, and away we go. We operate in, I guess, a model that I like to call trust but verify. So using Stash, we enforce a number of policies. So we have a minimum set of approvers for all pull requests. All of our sensitive branches, so our environment-based branches, can't be committed to directly. You can't even push merge commits to them. Everything needs to be done via a pull request, and then we've got some plugins that help manage policy around required reviewers for pull requests as well. So we have Bamboo in the middle, and from an initial look, you might wonder why it's sitting there. It's just basically taking a Git commit and getting in the way. So deployment. So production deployment in our environment requires a fair bit of due diligence. So PCI DSS, for example, requires segregation of duties around deployment versus development. So using Bamboo, we actually, for our production deployment plans, have the Bamboo build hold up and require a manual release, and that allows us to implement access control that provides a certain set of people ability to deploy to production and another set of people the ability to manage and merge code. So back to the R10K and the Puppet file. So as I mentioned with Chocolatey, we have no internet access, and that presents a bit of a challenge in the way that R10K works. So typically you have a Puppet file, it specifies all of your dependencies. That can be GitHub, it can be the Puppet Forge, but the Puppet master is the thing that actually fulfills those dependencies. It downloads them and makes them available. So our Puppet master has no internet access. And then finally, the trust aspect. So similarly to Chocolatey, we like to cast an eye over what it is that we're implementing in the environment. So how do we address this? How do we make Puppet modules available internally in our data center without opening up internet access? So we have a module workflow. So we basically, we go through a process whereby, for example, with Zach's RTK config module, it's up on GitHub, a developer can clone that down to their machine. We'll create a mirroring repository within Stash, and we'll push that up to Stash. So we've now got the module available in the environment. The question then is governance. So what we do is we take a branch off whatever branch it is that we're seeking to use. So in this case, master, and we call it Jesus master. So in our Puppet file, we declare our module dependencies and we pin it to that Jesus master branch. And as changes are made upstream in GitHub, we then go through a process whereby a developer can pull those changes from the GitHub remote, push those changes to the Stash remote, and then raise a pull request from the master branch on the Stash remote to the Jesus master branch. And in that way, we then implement code review over community code that we implement in the environment. So, been talking a lot about environments. So when is an environment not an environment? So, the best way to kind of figure out if this particular part applies to you is ask yourself a question. Do you want to be able to stage a rollout of Puppet code out across, for example, one half of production, see what happens, and then the other half of production? If the answer is yes, Puppet environments, your production environment is not a Puppet environment. Your production environment is an application environment. A pattern's been defined in the community. It refers to sort of an application environment as a tier. So Puppet environments exist to apply different revisions of code to different nodes. You need to not think of a Puppet environment as UAT or system test or SID or production. It might be the case that you just want the same code to apply to the whole UAT environment. In that case, fine. But if you want to be able to do a stage rollout, that no longer holds true. So typically, your application environments or your tiers are how you want to manage the configuration for your code. So again, Luke touched on Hira as the method to abstract out the data from your Puppet code. So typically, for example, you want to have a set of configuration data that applies to production. So if a Puppet environment is not your production environment, but you want to apply a consistent set of configuration across that environment, the question then is, how do you actually manage that? So if you use a Puppet environment, it'll work very well until you try to use Hira. So if you use Hira and you Hira based on the Puppet environment, you'll end up having production A, production B, DR A, DRB, and each of those files will essentially be direct copies of exactly the same thing. You'll be, to make a change in your production environment, you've now got to make sure that all 4 of those files are exactly the same. So a solution to that is the addition of, again, a custom fact to the environment. So we've implemented this similar to how we've done the role fact, so we can just Puppet config set tier production. And then what that allows you to do is configure Hira to resolve your configuration based on not the Puppet environment, but the particular application environment or tier that you're deploying to. I realise for people who haven't used Puppet before, this has probably just completely gone over your heads, but remember the question. If you want to be able to stage parts of your Puppet code out across a single application environment, you need to come back and have a look at this type of a solution. So another great lesson that we've learnt, and I owe this to Brett and Zach, who've spent a fair bit of time with us in helping us mature our environment, is to use Puppet to manage Puppet. I mean, it kind of sounds like a no-brainer, but it is also a bit of a chicken and egg situation. You're implementing Puppet for the first time. The first thing that you implement is the master. Well, how are you going to be able to configure your Puppet master given that you probably don't really know what you're doing? So as an example, so one thing that you could do is you could SSH into your Puppet master, you fire up Vim, open up Hira.yaml, just type in some changes and away you go. You could alternatively use a Puppet module that allows you to declaratively specify how you want Hira to be set up on all of your Puppet masters, but that doesn't seem like too much difference in terms of the lines of code, and that doesn't seem like too much work. I guess where the value really kind of comes into it is when you actually want to start doing some of the things that I've spoken about. So setting up R10K, setting up webhooks, managing your workflow a bit better. So here's an example that I don't expect you to read, but this is using the R10K configuration module, and this snippet of code does a number of things. This will install Ruby gems on your environment. This will configure R10K through YAML files. It'll actually take over part of the management of your Puppet.conf on your server and start to manage your module path for you. It'll install an M collective agent for R10K, and then kind of further down off the screen there are other options in terms of setting up webhooks so that you can remotely trigger R10K deployments, things like that. So that kind of covers off some of the key lessons and things I wish I'd known at the beginning. And now I'm going to talk about something that I think is interesting in terms of our approach to storing sensitive information in HireUp. So, again, we're a high assurance environment. We need to, security is a key concern for our platform and our applications. So in HireUp, you may want to be able to store sensitive information. You might want to store passphrases, things like that. So HireUp is a flexible tool. It supports the concept of custom backends. So a backend has been written called HireUp YAML, and it implements a public-private key cryptography model. And there are other solutions out there. There's a HireUp GPG solution. The thing I quite like about the HireUp YAML solution is it only encrypts your values. So your YAML file is readable. You can see what's going on in your YAML file without having to, for example, decrypt it. Now, there's a challenge in our environment in terms of the implementation for HireUp YAML. So, kind of swapping it around. So on the left-hand side, you've got the configuration for HireUp YAML, and part of that configuration is specifying the location of the private key that's used to perform decryption. So, those of you who are familiar with public-private key cryptography and operating in high assurance environments, you might notice that private key is actually stored on the same file system as the encrypted data. So the analogy I like to use for this is it's a bit like storing your PIN and your credit cards in your wallet at the same time. So it's not necessarily a bad thing. A disclaimer, right? Don't store your PIN in your wallet with your credit card. But what I'm trying to say is there's a risk-weighted decision that you need to make. If there's $50 in your wallet and if there's $50 available on your credit card and you'll know when it's lost and you can call the bank and it can be cancelled relatively easily, then maybe it's not so much of a concern for you. If your credit card clears $30 billion a month, you perhaps need to apply a little bit more governance around your process. So the solution that we've implemented, and I say we, I kind of came up with the idea, and we engaged Puppet for some help in the implementation. We're not Ruby devs, and we're not Puppet experts, so we turn to the people who know what they're doing in that regard. So who knows what a hardware security module is? Show of hands. Some of you. So hardware security module. For those of you who know how these things actually work, I'm going to kind of abstract away some of the complexity. But basically, the idea with the hardware security module is it's, in this case, a network appliance that provides very secure cryptographic key storage. It also provides acceleration for cryptographic operations and offload functionality. So as an example, so the HSMs that we use, if you open them up, and then, so you pull them out of a rack, open them up, plug the power in, they wipe themselves. If you open them up without plugging the power in, get into the internals and try and access the part of the appliance that has the secure cryptographic material on it, you find it's encased in resin. If you try and break through the resin, it'll destroy the chip that's inside it. So there is physically no way for someone to access the private key material that's stored within the HSM. Now, this is not necessarily for everybody. There's a cost that comes with these types of devices, and the cost is kind of twofold. One is they're expensive in the first place. but secondly, there's a lot of governance that you need to apply in terms of implementing and managing them. So what we've done in terms of integrating Hira and Puppet with these HSMs is we've engaged a friendly man down the bottom, Zach Smith. He's built an encryption mode for the Hira YAML plugin, and so that encryption module interfaces with the hardware security module to perform all of the encryption and decryption operations, so that the challenge of having your private key stored on the same server, on the same file system as your encrypted data is now no longer an issue. So we ran into a couple of challenges throughout this process. So the first implementation that we did, we used a shared objects file that's made available through the vendor, so it's a native binding through RubyGem. We implemented it, it worked great, and then Zach came back the next day and said, we're moving the Puppet Master to JVM, JRuby won't support native binding, so what we've just done will work fine now, that as soon as you upgrade to the next version of PE, it'll all break. So there's a second implementation that we've done, which is basically using OpenSSL and using the cryptographic hardware interface library function within OpenSSL. So that removes that hard dependency on a native interface there. So at the moment, the implementation is pretty simple. It's just RSA, public-private key pair. There's a limitation at the moment in terms of if people are familiar with RSA. But if you're using straight RSA, there's a maximum size of data that you can encrypt, which is the block size, which is defined by the key length. So at the moment, that suits us fine. I mean, we don't need to store very long pieces of sensitive data in Hira, but there's an option later on to expand this out to, for example, implement PKCS7 or CMS type crypto functionality, again backed by the HSM. So I guess from a dev's perspective, what does that look like? Well, the private key is stored securely on the HSM. The public key is exported, it's version controlled along with Hira. So from a developer's perspective, they can just use the YAML tool, specify the custom encryption modes based on the gem that's being developed, and they can encrypt a secret, take the block, paste it into a Hira YAML file, and you're away. So, kind of in summary, some of the things that I've covered. So, you've got to keep in mind, Puppet is code. Abstractions are really important. The roles and profiles pattern is something that we've found to be exceptionally beneficial in aiding the readability and maintainability of our Puppet code. Classification at the node is something that has worked well for us in terms of just inverting the classification process. But again, Puppet Node Manager is something that looks like it will also provide a solution in that environment. Chocolatey on Windows is fantastic. Again, if you use Windows and you haven't used Chocolatey, go to chocolatey.org once you get home and go crazy. It's fantastic. R10K, use R10K. It's again, if you want to have a dynamic workflow, it's an excellent implementation. But R10K is a set of technologies that will help you implement your workflow. The important thing is to make sure that, regardless of the tools and systems that you've got in place, you think about how your team works, the governance requirements around what you need to cover off. Puppet environments aren't application environments. Again, if you're a beginner, that won't make much sense until you actually try to do it, and then hopefully this will trigger a memory back to here. Use Puppet to manage Puppet. As soon as you set up one Puppet Master and you need to set up another one, you'll thank yourself. And so one thing that I've kind of sort of glossed over at this point, up till this point, is the Puppet community is fantastic. So apart from the Hira YAML HSM integration, I've basically been parroting things that much smarter people than me have come up with, and they've taken a lot of time to engage out with the community, document their thoughts, and kind of make these patterns available. So, the PuppetConf and PuppetChem talks, and then there's a few links I'll put in at the end for further reading. And then storing sensitive information in Hira. So I guess kind of as a wrap up, so looking where we were in March, where we are now. So we started this journey in March. We've now got AppDynamics, Splunk and Puppet all operational through all our environments. We actually rolled out AppDynamics and Splunk from the agent perspective using Puppet, and that was something that worked very well. So we're working on Vagrant. We've got a functional Vagrant workflow using the Vagrant vSphere plugin. So we can provide, the aim there is to move on to building the ability for testers to request and provision on-demand testing environments into our virtual center development environment. And we're now at the point where our architecture and our implementation and our framework is stable, and we're now starting to broaden the usage of Puppet out across the wider team from the core group that's been responsible for the implementation. And then I guess a couple of key thanks. So within my team, I mentioned the use of cheap and/or free graduates. Dylan Ratcliffe and William Gord, who are here today, have done a fair bit of work to get us where we are today. They've been dropped in the deep end, and they've done an excellent job of it. And then Laith on the application operations side as well. I'm the apps dev guy. None of this would have been possible without a really good partnership with our infrastructure team. So the Jesus infrastructure team, Lee and Satish, and then also backed by the team at Net Solutions as well. If anyone from an app side of things is thinking about looking at Puppet to address some of these challenges, it's absolutely vital that you bring your infrastructure guys along for the journey, because the whole thing about this process is kind of improving collaboration and bringing those groups closer together. So from the Puppet side, Brett and Zach, Gary, and then Craig have done some great work as well in terms of defining some of the things that I've spoken about, and then Rob Reynolds for Chocolatey. If you do use Chocolatey, you might not be aware there's a Kickstarter going on at the moment, so Rob wants to kind of take Chocolatey up to be a commercial offering. If you like Chocolatey, go and check it out. And then this will show up in the slide notes, so some contact information and some links for various things that I've found to be useful. Questions?
So it sounds that your organisation, you don't differentiate between infrastructure guys with their Puppet Master and app deployment guys somewhere else. It seems like you have a fully integrated team, is that right?
Yeah, I mean, so, part of the reason that we can deliver the value that we do to the business is the fact that we are a relatively small group, and we have ownership and visibility of the full end-to-end. So hardware and networking gear all the way out to the application. I mean, we don't have to, if we want to provision a virtual machine, we don't have to talk to storage guys and networking guys and firewall guys, all that sort of stuff. It's a very, very tightly integrated team, and that's what's allowed us to do things like, for example, implement Puppet plus all of those other toolings in the space of March to now.
Are you thinking about sort of expanding the capability to include provisioning as well?
Yeah, so the provisioning is interesting. At the moment we're using Vagrant just to do the provisioning on the dev side of things, but that's not necessarily a tool that you'd want to use within an actual environment. What you'd want more in an environment is a way to, similarly to the Puppet language, declaratively specify what you want an environment to look like in terms of VMs. There are tools like Terraform, which is from the guys who've done Packer, for example. So I think they're sort of heading in the right direction, but at the moment, our environment in terms of our production environments is a relatively fixed environment. It's not a huge challenge, but we're kind of monitoring what's available, and once something comes up, we might pick that up.
I was just looking at the applications that you're using, and there are other more conventional ways of doing it.
Yes.
What advantages did you gain from, and it just also seems there's a bit of a convergence of, we don't care what the operating system is, we just want to do DevOps, whether it's Windows or it's Linux.
Yeah.
It seems to be going in that way.
So can I ask a question to your question? So define traditional.
Oh, well, I was at SCCM to deploy an application.
So I've worked in an environment where we use group policy and then SCCM to do package management for end user computing. Would I use them again after using Chocolatey and Puppet? No way. I mean, the ability to have the combination of the end-to-end workflow for kind of the development, testing, and deployment, plus then kind of the simplicity around the infrastructure. It's a no-brainer. SCCM, it's an absolute beast to install and configure and manage and make sure it runs properly. So the tooling that we've picked here, we've picked. As I said in the decision between Puppet Enterprise versus open source, we want things that we can put in the environment and have work. SCCM is something that you put in an environment and then you have a team that works it. So yeah, that's kind of the rationale between those decisions. Exactly. Yeah.
Okay, thank you, Keith. I think we're out of time.
Thank you.